Welcome to SIM-PAC Live. I'm your host, Jeff Matthews, and today we talk to Sofia Katzin, Managing Director of FlyMumma. FlyMumma is a consultancy focused on improving efficiency and innovation in insect farming, agri-science and sustainable food systems. Sofia works with clients globally, specialising in black soldier fly production and broader agri-food challenges. Welcome, Sofia.
Hi, Jeffrey. Thanks for having me.
Thank you for coming on. I'm really fascinated about FlyMumma and also black soldier fly production as a topic. And one of the reasons I'm fascinated is last year in an interview I said there was nothing truly circular, maybe subsistence farming. But when I look at black fly soldier production, it's probably the most circular thing I've seen out there. Can you take us through what black soldier fly production is and why it's so circular?
Yeah, great. Thanks for your interest and fascination. Since I made these flies 5 years ago, I can only think on waste transformation into higher quality ingredients for the animal feed, which is essentially what insect farming does. And it's really replicating nature. We always see chickens or fishes getting things from the soil. In the case of chickens or birds, they get the little grubs, they eat them, digest them, then they do the poopies, and the manure sit on the soil, and then the soil is degraded with insects, which then can be eaten by birds and chicken again. So we are doing this at a large scale in an optimized setting and trying to reduce costs and produce safe products. What we do, in just other words, we take food waste, organic waste from supermarkets, hotel, houses, food industries. We use the insects and we turn it into protein, like whey protein that you can drink after the gym. Well, we do the same, but with insect protein, and it's usually for animal feed. It's not for humans just yet, but who knows in the future.
And I gather that this whole process, the whole life cycle of a black soldier fly through larvae is a very quick process. It's a very quick protein process. Take us through that life cycle.
Absolutely. It's only 35 days. 7 days of that, it's the adult life. So when it's a fly, they don't eat, they just reproduce themselves. The female lays the eggs, which then they hatch into baby larvae. We call them neonates. It transforms into juvenile, it's like a teenager, then into fully grown adult larvae. Then prepupae, where they stop feeding, turns into pupae and emerge into a fly, just like a butterfly that it was a caterpillar before. And as I said, 35 days from egg to egg. They have a feeding stage, which is the larval, and then all the rest it's non-feeding. So it's a great insect because they don't eat. So then they don't bite as adults. They are not like houseflies that can transmit diseases or pathogens. This is a very safe fly.
And it's in the larvae stage that they consume waste, and they consume a lot of it. They consume, I think, 50 times their body weight.
Yes, that's exactly right. They are very hungry little animals, and they can grow up to 10,000 times their weight in only 7 days.
10,000 times. They grow 10,000 times in 7 days.
Yes,
Wow.
yes, yes. They go from like very little, like microscopic neonate to like fully grown larvae.
And when they consume the waste, how much is that a reduction in volume of organic waste?
It will depend on the type of waste. If we have more fiber materials, it will be a little bit less reduction. But if you have just like restaurant waste or catering waste or bread and a little bit of proteins here and there, it will be 85% volume reduction. So this means that we start with 1 ton of organic material and we will end up with 150 kilos of insect frass, which is the insect manure and can be used as a soil improver.
Wow. And so you go from 1 ton to about 400 kilos of protein, or did you say
Correct.
450?
Yes, yes. So from 1 ton of organic waste, you will end up with 400 kilos of live larvae
Yeah,
and 150 kilos of this frass. Then
right.
the 400 kilos of live larvae then can be used for chickens, backyard chickens or fish ponds, or it can also be processed by microwave dehydrating to extend the shelf life, and then you will end up with high quality protein feed.
And this high quality protein, it's what 60% protein or something, but it's also got 15% fat, but it's also got amino acids in it.
Correct.
So so that's why it's good for animal feed.
That's it. That's it. Yes. So the protein, it's an animal protein and it has the essential amino acids that chickens, fishes, pets need for healthy growth. Lysine, methionine. It's great. And not only amino acids, but also the good fatty acids. It has lauric acid, which is very similar to coconut oil, and it has great antimicrobial properties. So it can be used as the natural antibiotic and replacement for antibiotics in pig feeds to prevent piglets dying from diarrhea.
And I gather the flies, not only do they reduce the waste, they clean it up, and they reduce the incidence of salmonella and E. coli, and actually make what's left over, the compost, a high quality compost even.
That's it. Yeah, that's exactly right. Because of these kind of very high packed nutrients that they have and these antimicrobial properties with the lauric acid, they can reduce and fight against pathogens. So we have done, there is a lot of research around the world, but I participated in one testing where we receive high pathogen manures, chicken manures, pork manures, and after 7 days with this insect bioconversion, those microbials, so the E. coli and salmonella, were reduced 7 times folds. So it creates a safe product for later uses.
And also these properties that the waste, you call it FCAS. What do you got a name for it? You got an acronym for
Frass, the
FRAS.
insect manure.
Yeah, FRAS, insect manure. By putting that on the plants, it stimulates response from the growing plants to be more pest resistant.
Exactly. Yes, yes, that's correct. That's correct. Usually in the industry, after these 7 days of insect bioconversion, there can be a further composting stage where the phytotoxicity is reduced, and then it can be applied to plants and create a great environment full of the good bacteria that will stimulate growth on plants, celeries, tomato, and even broadacre. In particularly, I can speak for the case in Western Australia, where we have very sandy soils. Adding insect frass can improve the aeration and the texture and the water holding capacity. So in the case of a draft, the waters will have better resistance.
Right. So let's just say you're solving a waste management problem. You're improving compost that's left over from the waste for the soils. You're producing high quality protein for feed, and some of this feed that you're replacing, say in aquaculture, that's feed that's problematic with sustainability, isn't it?
That's correct. That's correct. So to feed farm fish, you will need to get a lot of wild caught, and with that wild caught, you get bycaught, so dolphins, turtles, etc. And
Yeah. Yeah.
yes, and the price volatility of the fish meal, that's the thing. Like it's not only for sustainability, because it's a beautiful buzzword, sustainability, but if it doesn't come with the price tag. Some companies don't really look at it. We have seen in COVID times an increase in the fish meal price. It went from $2 per kilo to 3 kilos. And it's only going to increase because we're going to run out of fish. So insect protein, it's a great replacement. We have done tests here with barramundi, salmon trout, rainbow trout, salmon, tilapia, replacing up to 100% of the fish meal with insect meal, and we saw no negative growth on the fish.
And also, what about other uses? I've heard that there's been some testing for biodiesel and also use in pharmaceuticals.
Yes, that's it. So another uses, which at this stage they are under laboratory research, they are not proven commercial technology, which I'm sure they are going to be in the future, but not just yet. So as we said, we can extract the protein from the larvae, and we can also extract the oil. Then the oil can be used as a biodiesel, and then there is companies in Middle East doing the feasibility studies to prove that it can be used as a sustainable aviation fuel. And in the case of pharmaceuticals, the skins of the flies have melanin that can be extracted for pharmaceutical uses to treat different diseases.
And what about what's happening in Australia? Tell us, have we got any of this in commercial production in Australia?
Yes, we do. We have a couple of companies. GoTerra is leading the space. So rather than focusing on animal feed manufacturing, they are more focused on the waste management side of things. So the business model essentially is charging the waste producer a feed that is going to be cheaper than the landfill gate feed. And then they install modular containers that can treat, let's say, 1 ton of organic waste per day. And in 10 to 12 days, the waste is reduced, the volumes that I said before. And they have installed the containers all across the East Coast and soon starting in Western Australia as well. That was GoTerra. And then we have other smaller producers. We have Viridian, Vardi, Arcento, which focus either on waste management or animal feed manufacturing. We also have FlyFarm in Brisbane. They produce technology to support the growth of the company's automation robotics. And we also have Arvela here in WA, which do only the reproduction side of things.
And what are the barriers to scaling this up? And where is it being implemented around the world?
Yeah, so there is a few barriers, and it usually comes with the biology. So when you try to scale up, it's not a linear production. It's more like exponential because you will have a lot more heat. So you have to extract that heat from the containers or wherever you are growing your insects. You will need a lot of ventilation. You will need to cool down the facility. So at this stage, the industry is working on more smarter ways to have an optimized climate without that much need on capital expenditure. Another, in scaling up, we are not really limited by space because it can be done as a vertical farming. So either like conveyor belts or plastic trays stack up together in a container. So to give you an idea, in a 40-foot container, you can receive 1 ton of organic waste, put it in to these trays, and then seven days later, you will have your frost and your larvae.
Right. And I suppose the other bits to what you need, energy, and heating, cooling, that can all be done with renewables. And so and the flies lay a lot of eggs, so that side of it can be scaled up. So it's really how you manage the waste coming in is going to be the most difficult point. from any for any large scale. Do you see the plants getting larger, or do you see them being more containerized and being more distributed?
So that's a great question, and it's perfect for this time in the industry where we saw a lot of companies that previously were more around the centralized facility where they transport the waste from different farms or food industries to one location where they treated 100, 300 tons of organic waste per day. That system, it's not really what we're doing at the moment. The industry is looking to decentralized models where rather than transporting the waste, we are transporting the insect to modular containers that treat smaller to medium volumes. And I'm talking 10, 20 tons of organic waste per day, which is scalable. It's easier to control. It requires less capital, so
Yes.
you can raise as you start producing.
So, is the protein production side of it commercially viable? We understand the waste management in effect, and it's a very effective waste management. Is it commercially viable?
Yes, yes. So we are trying to demonstrate that. At this stage, the conversation, there is a lot around, yes, it's more expensive than fish meal at this stage. Yes, but this is a solution that it's going to be applicable in 5, 10, 50 years where we don't have any more fish meal. It's not going to be cheaper or more expensive. It's just we are going to run out of the resources that we have at this stage if we keep doing linear systems. Yeah,
Well,
so
it's also the freighting of that stuff around the world. The fish meal, that comes into New Zealand, for example, comes from South America, comes from off the Argentinian coast where you come from.
yes, yes,
but so having distributed sources of protein using that circular economy, using the waste that we're producing, and having it come back, and 1 ton of waste coming back as 400 kilos of high quality protein for feed. That's once you start putting in the carbon taxes and the freight costs of those things, that's going to be important going forward.
That's it. And now the challenge is really learning from the mistakes that companies did in the past. I have to mention it, it's not great news, but there were a few companies in Europe going bankrupt in the past 12 months. And it's not because the industry, it's not going to work. It's just that they were targeting these centralized models. And now we know that it's better to do it small, modular, and slower growth. Like still fast, but not going from 0 to 1 million within 6 months.
Yes. Just because you can breed the flies that quick doesn't mean you can have the whole system work that quick. Has anyone done any work on the? I would just, from the top of my head, look at it and go, well, this is carbon negative, or it has to be, because letting waste, convert itself into methane is very damaging for the planet, and the larvae converting that waste is reducing the emissions from that methane, and I would imagine they're not producing that much CO2 themselves. So this whole process could be quite negative CO2 or negative emissions, if you like. Has anyone done any work around that?
Yeah, that's it. That's exactly right. And there is a lot of companies in Europe leading that space with emissions and how we can monetize a little bit this industry as well. Larvae do not generate methane, and that's the beauty because it's not anaerobic composting. It's not anaerobic fermentation. It's actually aerobic. We do work with oxygen. Um, and the larvae will generate a little bit of ammonia and CO2, but it's very small compared to the methane that can be produced in landfill. And also in Europe, there is a lot of companies working on scrubbers to avoid any release into the environment.
I've got one more question for you.
Sure, I can speak the whole day about insects.
What's it taste like?
I think there is a lot of room for improvement. At this stage, they taste like nutty, like crickets, mealworms, but with the right seasoning and the right other ingredients, I think in a few years we will be eating insects for sure.
Okay, Sophia, thank you so much for the interview. I've learned so much talking to you. We're going to have you at SIM-PAC Live Western Australia. We're going to have you speak. Looking forward to that.
Absolutely. Looking forward.
Okay. And yeah, good luck with your business, FlyMumma. I'll put some details up so people can find you if they're looking to get into the business.
Great. Excellent. Thank you so much for having me. And I will send you some samples for you to try and you tell me how they taste.
Perfect.